Hey guys, so today we are going to be taking it a step further on our chemical reactions and testing mixtures. So today we have the potential for creating extremely cold or extremely hot mixtures. Therefore, we need to step it up a notch with our safety protocol in the lab. You must stay in your group. You cannot wander around the classroom during this time period. If you do, you will be asked to leave and you cannot participate in the rest of the lab. You cannot walk around with chemicals. You cannot walk around with your mixtures. I know you're going to get super excited about the things that you create, and you're going to be tempted to share with people in the classroom. That is what your iPad and your recording is for. So please focus on sharing through the lens of your iPad rather than trying to walk around. Because if you bump into someone or your baggie happens to melt, we could have a real problem on our hands when it comes to safety. Also, we have in years past had major mixtures spilled in the classroom, and then we had to stop the lab for everyone because there were no more chemicals for everyone else to use. So don't walk around with the chemicals. If you need something, raise your hand. I will be the one to take chemicals from group to group. Okay, I'm the only one that's walking around with them today. Okay, with that being said, today you have I don't get this whole concept, but it is from my side and it is actually a zombie challenge. Um so today you're taking it to the next level. You started with the mitten lab trying to figure out what would be the best design or best mixture out of the two to create the perfect hand warmer. Well, now you have a set of criteria that you have to follow. And this is your scenario from my side. All right, you ready? So here's your problem and your criteria. It's post zombie apocalypse, which means it's after this whole thing has gone down. There are zombies everywhere, right? And winter is coming. Your ragtag group of survivors are in charge of creating hand warmers using the limited resources left after the panic and destruction. Okay, there's hardly anything left. You have found some just random things, and you need to be able to create the best combination to keep you warm and safe during the zombie apocalypse. Your job is to find the best combination and concentration of chemicals. So it's not just, hey, which one should we mix, but how much you need to use. Okay. So you have to create, this is your criteria, things that you must do. Okay. Your protocol, it needs to be warm. So your mixture needs to increase in temperature. It needs to be safe. So humans don't actually come in contact with the chemicals. You're not using anything with your hands by combining them, okay? And it's portable. So you can actually move these things around without it being activated. That's the big challenge, okay? You are not going to touch the chemicals, and you can travel around with these things without them being activated until you choose for them to be activated, okay? So, resources are limited, so we must find the optimum combination, the best combination, and not waste chemicals. Groups will test their original ideas, share their results, and then afterward, groups will have the opportunity to evaluate and redesign their prototype. So, this is a really big, important part that we did not have last time. Okay. You are going to create your first round, test it out, see what happened. All the other groups in the class are going to do the same thing. Okay. When everyone shares out the results, it's going to be extremely important for you, your group, to take notes, right? Because you may have only worked with like 3 chemicals, right? And you're going to know how those 3 reacted to one another. But what about all the others that were possible? Okay. So everyone in class has the opportunity to use any kind they want. And if they find a mixture that works pretty well, or maybe they find a mixture that's terrible, you know to avoid that and not do it for your second round. Okay. So the first round is everyone just testing and sharing out what you find. The second round is what we are talking about when we get to evaluate our results and redesign our prototype. So the second round is going to be based off of all of our original findings, because you're going to notice whenever I give you the possible lists materials, kids are always like, what the heck is this? Like, how am I supposed to know if water jelly crystals are going to mix well with iron fillings, right? Like, how are you supposed to know that? Well, you're not, right? So that's why you get to test it and a whole bunch of other groups get to test it, share out their results, and then you do a redesign. Okay, so it's kind of blind testing here, this first round. Okay. No, you are not allowed to actually Google, like, what will happen when you mix sand and water jelly crystals, because that would be boring and pointless. And what's like, that's what we all want in our science class, is to be able to explore and find things on our own rather than just using an iPad, right? So that's the purpose of today. Don't Google it. If you really want to know what something is, you can Google the actual like material to get a background on the material, but don't Google how it mixes with others. There's no point in cheating. They're like, no one's going to get an award for this. It's just for fun. So do the inquiry process like legit. Okay. Just test them out and have fun with it. Okay. So you can Google the specific material and what it is all by itself, but not how it mixes with anything else on the list. Cool. All right. This here says constraint on an amount. Constraint means it's a limit. Okay. You cannot go lower or higher than this amount, less than or greater than. Okay. So our math kind of comes into play. So if you are going to use any kind of, like, let's say water, right? You have to use at least 5 milliliters of water if you're going to use it, at least 5. And you cannot use more than 75 milliliters. Okay. So you have to stay within that range if you're going to use it. Okay. This is not saying you have to use 5 grams of CaCl2 and 5 milliliters of acetic acid. You don't have to, but if you choose to use that material, you have to fall within this category. Make sense? Because otherwise, like, it's kind of hard to test if you decide, I'm going to use 3 droplets of water. Like, use a legit amount that you're going to measure where it's substantial enough to affect your overall results. Okay, so that's kind of why that range is there. If you choose the material, you have to stay within that measurement range. Okay. If you choose to just use 2 things, totally can, right? Should you use all of them at once? I mean, technically you can, but if you have poor results, how are you going to know what caused what? There's too many variables in that experiment to really have a true test of anything, right? The fewer variables you have, the more you're going to learn from your design. That's all I'm going to say. Cool. Plus, I mean, it's just greedy. Okay. So, again, resources are limited, right? You're going to have one setup, um, share out, everyone sharing out. And then, based on the results that everyone shares out, you will have the opportunity to evaluate your own design and make a new prototype. Okay. It could be the fact that you like the way that they structured their hand warmer, like the physical structure of it. Or it could be the fact that you appreciate the chemical combination that they used. It's not cheating, it's science. This is how scientists build on each other's ideas. So it's important to gather correct data and share out, so that way we can all benefit from your results, if that makes sense. Okay. So, your background: chemical energy can be stored in chemical bonds. We've talked about what it takes for bonds to be created and for bonds to be broken, and how that affects the energy that's either absorbed or released. Correct? So, within this design, you have the opportunity, you may end up with an endothermic reaction or an exothermic reaction. And that'll be a part of our reflection process at the end. So we're going to figure out if energy was released or absorbed. Cool. So additional supplies, you're going to have a scale because obviously we need to weigh things out to make sure we're staying within that range. Graduated cylinders, plastic spoons, plastic bags, cups, and a digital thermometer. Everyone will get that. Okay, cool. So go ahead and stop the video. You guys are going to kind of discuss what you understand about the project so far and any ideas that you may have, and then come back and finish the video. All right, so for step 1, it says brainstorm before getting materials. No one's allowed to touch anything yet. You have a list of things. I've shown you visually what they look like, okay? Now you have to plan things out, okay? Because otherwise kids just kind of like mix and then you kind of forget what you even had. I've had that in years past. So your plan has to be approved by me before you can share out with your group, okay? So on your own right now, you're going to write down or draw a model of your idea. Okay, so what chemicals do you want to use? How much do you think you should use? And then draw that model. Okay, labels, everything. Okay, so like, are you going to have tape? Are you going to have plastic bags? Are you going to have rubber bands? What are you going to be using? I'm okay with any other STEM materials that you would like to create this hand warmer, right? Remember, you have to make something that creates a warm temperature. It increases in temperature. It's safe, so you're never going to come in contact with those chemicals yourself. And it's portable, so you can walk around with it, fight zombies and all that good stuff without it activating until you want it to. Okay, so this is your time for your brain to record whatever you want. Okay. And then part 2 is identify what factors cause you to select the combination of substances you thought would be most effective. So some kids on here, you might be like, I don't know, I just guessed, right? If you have no clue, write that down. Some kids may have a little bit of background on how these things might interact with one another. Some of you may take what you learned from our mitten design and apply it. It's up to you. That's all I'm looking for in this spot. Do you have any clue or was it just a guess? Cool. And then give me that. Pause the video, record all of your own specific ideas. I'm going to walk around and make sure everyone gets to use their own brains before you share in a group. That way no one like dominates the idea of your group. All right, you guys are ready for step 2 now, okay? If you're moving on to step 2, this means that we have all been approved. You've all used your own brains. You've all come up with at least some kind of concept, right? So now you're ready for step 3. Share and explain your ideas with your group. Okay, so you guys all are going to sit together, show your drawings, explain why you chose the materials that you chose, and come up with one plan. So you could say, oh, we just like so and so's plan. We're going to go with that. Or you could say, hey, we like a little bit of each of our plans. Let's combine them and create a new one. It's completely up to you guys. So pause the video here, talk amongst your group, come up with your one plan that you're going to go through and record it here. You need to have labels. So if you draw a box, label it Ziploc baggie. Okay. If you draw some kind of powder substance, label what the chemicals are and how much you're going to use. I want labels, 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 labels. Cool. You have to get approved before I will allow you to go anywhere near the materials table. Okay. Keep in mind, the longer you take to agree on a design, the less time you have to build. So, get going. Okay, guys, this is step 3. If you're moving on, you have been approved. You're ready to like work with your actual materials. Okay, so this is when you start recording for Flipgrid or Flip. Answer the remaining questions in this journal in your video. Okay, so make sure you're talking about this stuff in your video. Each person in your group needs to participate by explaining a part in your video. Be sure to show your tables and graph. Okay, so in your video, what chemicals did you decide to use and what amounts? Yes, somebody needs to explain the chemical and the amount. You can have one person explain each chemical. You can have one person explain all of them. It's up to you, but everyone needs to talk in your video. And then explain how to activate your hand warmer. So hold up those supplies. Show a close up of your design and how it's built and how you are going to get your chemicals to mix and activate. Cool? The next part, after you guys do all of that, you are going to move on to actually activating it and recording your temperatures. Okay. So in this part, it says use the data table below to collect temperature over 5 minutes. This is so important. Every year I have kids that just completely like space out on this part. And this is the entire lab right here. Okay, so you've designed it, you've decided on your chemicals, all that good stuff. Well, now you're ready to mix them, right? You're going to activate your hand warmer, you're going to mix them together, right? Okay, so this is what you're going to do. The split second that you guys mix them together and activate it, take your temperature. Cool? Okay. So you're going to take your temperature and record it right here. After every single minute goes by, you are going to record the temperature again. This is not a time to walk around the room or completely get sidetracked with a conversation. Set a timer if you need to. Keep a close eye on this, okay? The idea is if you activate this hand warmer, some of you guys may start out really slow, and then all of a sudden by minute 5, it's super, super hot. Or you may end up mixing it and bam, it's super hot right off the bat. But within a couple of minutes, it's really cold. Okay. So you're trying to get an overall idea of is this thing staying hot for a long amount of time? Like, how effective is this going to be over a 5-minute time period? Cool. So if you have time in class and you've done your 5 minutes, keep going. I mean, it's ideal if you can keep going for like 10 minutes. That is awesome. Okay. I have 5 minutes just to start us off, but you can totally keep going and like record and create your own table off to the side and keep going here. Okay. One tip when you are recording your temperature, like activate it, set it down somewhere, and you're going to keep taking the temperature from the same location. Okay. So if you're choosing like the lower right hand corner of your baggie, choose that same location every single time. Okay. Because if you start shooting around and taking temperature all over the place, or you have someone holding it in the air for the first minute and then you set it down on the cold desk at the second minute, it's going to totally affect your temperature. So, whatever you're doing in minute 1, you need to keep that same environment throughout the entire temperature testing time period. Cool. So, if you're going to keep it in the air, keep it in the air for 5 whole minutes. If you're going to put it on the table, put it on the table for the entire 5 minutes. Yeah? Okay. This is the last part. You guys have, if you're moving on, it is because you have finished taking your temperature for everything. You're ready to create a graph of your data table. For right now, before you guys even move on, I would say I'm just trying to point this out to you. You have a space for your title. When you're trying to graph a any kind of information, any lab whatsoever in science. You want your title to be pretty self explanatory, but it's not a paragraph. Okay. So this could just be zombie hand warmers. Okay. Um, Something very basic, right? Chemical reaction hand warmers, however you want to do it, right? And then when you're looking at this, we have our x-axis. It goes this way on a graph, right? And we have our y-axis. And this is fabulous because this is actually the unit we're getting ready to go into in math class as well. Some of you guys have already worked on this with me. So this is your x and this is your y-axis, okay? So whenever you are working on a graph, one, you need to have titles. People need to know what the numbers are going to stand for. So we're going to end up with numbers here in each of these boxes and numbers in each of these boxes, right? And then we need a label, okay? Units of measurement are going to go here. So does this represent time? Does it represent degrees and temperature? All of those things, right? So if you think about it, you need to always follow the same rules when you are graphing things in science, okay? So there is a way to do independent and dependent variables when you're talking about a graph. So the way that I remember it is that I know this is kind of weird, but you guys realize that I always have weird things to help me remember. Okay, so this is how I'm going to remember it. If this is my graph, right, I'm going to remember that I have this axis here, right, and I have this axis here, right? Okay, so if I go through and I make this, I'm essentially making an I for independent variable. Boop, 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 boop. Which right now might not mean so much to you, but your independent variable is what you're starting with. Okay. So your independent variable is always going to go on this line here. Okay. So what you're starting with, that's your label, that's what starts down here. And then if you have your dependent variable, I always think of this as your axis. Oh my God, I'm getting a little crazy. Okay. This is your y-axis, right? And I can make a D out of that for dependent variable. Okay. And again, I'm drawing on my computer pad, so that's why I look a little derpy. Okay, so dependent variable can go right here. Okay, and your dependent variable, those are your results. Okay, so if you're thinking about your results in this specific lab, think about it. What are you actually trying to figure out in this lab? So, if you think about it in this lab, you guys are going to be looking at the results, or it's also another way of saying, what are you measuring? Okay. And in this lab, you are definitely um, looking at time and how it's going from 0 minutes to 1 minute to 2 minutes to 3 minutes. And you are measuring the temperature at each of those intervals. Okay. So, your results are not 0 minutes, 1 minute, 2 minutes, 3 minutes, right? That's silly. Those are not results. Those are just increments of time, right? So your increments of time are going to go down here, right? And then your results are going to be what you're measuring in your temperature, okay? So after 1 minute, what was your temperature? After 2 minutes, what was your temperature? That's what you're kind of looking for. Okay. So I have these labeled as like a dot plot. So at here, this is at 0 minutes, right? At 0 minutes, what was the temperature? That's where you're going to plot. Do, 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 do. Okay. And then at 1 minute, let me go through. I'm going to try to make this a little bit more visual for you. Okay. So this line here in pink represents where you're going to plot after 1 minute, what was the temperature? Okay. And after 2 minutes went by, you're going to plot somewhere along this line the temperature, right? And after 3 minutes go by, you are going to plot somewhere along this line. And what I mean by that is let's say this is I don't know, we're going to say at least we're going to start off at 60 degrees. I have no idea. Okay. We're going to say 60, 65. Please excuse my handwriting again, right? I'm not saying you have to use these increments at all. I'm just going off of what could come to my head right now. Okay. Oopsies, this would be 80. See how I'm counting by regular increments? You don't have to start at 0 here. Otherwise, we wouldn't be able to fit everything on here. But I'm counting by increments of 5. So 60 degrees would be here. So let's say at the very start of my experiment, it was at 73 degrees. I'm going to plot 73 like right here and put a dot. See how it's between 70 and 75? So this dot represents 73 degrees at 0 minutes. Cool. And after 1 minute of passing, it is now increased to, I'm going to say 95. So this is 80. This would be 85. This would be 90. This would be 95, right? So I'm going to say after 1 minute, it goes up to 95 degrees. I'm going to plot it right here at 95 degrees. Well, after 2 minutes have passed, it already starts going down and it's at 89 degrees. So I'm going to put it here. And then after 3 minutes have passed, it is at, I don't know, 75 degrees. I'm going to put it all the way down here. See where I'm going with this? So this is actually how many minutes have passed. Okay. Minutes. I wish there was a type. There's not a type option for this app that I'm using. So minutes activated. So pretend this word, I'm going to just type it out. Activated. So this is how many minutes your hand warmer has been activated. Sorry, I can't talk and spell at the same time. All right. So this is how many minutes it's been activated. So like I said, on your little piece of paper, I only did it up to 5, but if you have the time, keep going for sure. That's even better results, right? And then over here, what do these numbers represent again? Temperature. Okay. So this is temp. You're supposed to do temp in Celsius. I'm not forcing you guys to do Celsius because I feel like kids don't really understand what that means. In science, you should use Celsius as a true scientist, but in class, if we're just now starting to get comfortable with measuring things, I'm okay with you using degrees Fahrenheit because that at least gives you an idea of what these numbers even represent. Okay. So notice I didn't just put temperature, I put degrees Fahrenheit. Cool. All right. So that is the very last part of your overall lab, right? We're going to go through and do step 5 evaluate later on. Okay. So that's a whole separate video.